Welcome to this tutorial that looks at naming using IUPAC formatting. So what we're going to do in this tutorial is we're going to have a look at a range of different organic molecules, and we're going to look at how to provide a systematic name for it and also how to provide the semi-structural formula. So the systematic name is the same kind of description for IUPAC naming. So in chemistry, it's important that all molecules, whether you live in Europe or you live in China or you live in Australia or wherever you are, that all chemicals have the same way of being named. And that's really important because if there is a difference in the naming and somebody uses a chemical on one side of the planet compared to the other, you may be using the wrong chemical, and therefore it can lead to potentially dangerous reactions. So it's very important to name it consistently. Now, the way that we name using IUPAC formatting is we always choose the longest carbon chain possible. So in this situation, it's not too difficult to see the longest carbon chain. There is only one carbon chain, and that is this one here. Carbon number 1, carbon number 2, carbon number 3, and 4. And then we have to identify also the functional groups. So the functional groups are the non-carbon and non-hydrogen parts of the molecule. So we can see that there are actually, on that molecule, there are two functional groups. This type of functional group is called hydroxy functional group. So we will use that in the name, in the IUPAC naming. So the way that we put together the name is you have to actually identify what carbon number the functional group is on. So you can see that this particular hydroxy functional group is positioned on carbon 1, and then this particular hydroxy functional group is positioned on carbon 4. Okay, so you always actually want to assign the lowest carbon number to the functional group, but in this case it isn't possible because you have one hydroxy functional group on one side of the molecule and then another on the other side of the molecule, so it may not be possible. So the systematic name would be 1, 4, because we have hydroxy on the first and the fourth carbon, and then we have to mention that we've got hydroxy. But because we have two hydroxys, we need to give it a prefix of di. Di means 2 in chemistry, so di is equal to 2. Tri is equal to 3. And then tetra, which you probably won't get up to, is 4. So whenever this is looking at functional groups, so whenever you have two functional groups on the molecule, no matter where they're positioned, but if there's two of them, you always have this di in front of the name of the functional group. And then what you do is you have to provide the longest carbon chain. So we know what the longest carbon chain here is. In this case, it's 4 carbons, and from your counting, counting chemistry, we know that meth is equal to 1 carbon, F is equal to 2 carbons, prop, and then we go to bute, which is equal to 4 carbons. So this is bute. This would be called bute, and because there are only single bonds between each of those carbons, it's called butane. So that's the name for the molecule. Now, there can also be another way of calling this molecule. So that's one way. And I know what you're thinking. You're thinking, hang on, isn't there just meant to be one standard way of calling them? It still follows the IUPAC formatting. So chemists around the world will understand what it means regardless. Okay? But this is another way you can call it. So you can call it butane. So because it has an OH, it's referred to as butanol. But since there are two functional groups located here and here, what we can do is we can convert that at this point here between the N and the O, we're able to replace butane and 1, 4 ol. So now I've made a mistake there, and the mistake that I made is I forgot to add in the di. And the di goes at the very end in front of the ol. So it's called diol. So it's butane 1,4-diol. So these two are exactly the same name. Now the semi-structural formula, in this case, you have to write the OH from there. Then you have to write this carbon with 2 hydrogens, same as this one, same as that one, same as that one. So we've actually got 4 lots of those 4 repetitions. So CH2, 4, and then OH at the end. So that's the name. That's the semi-structural formula. So semi-structural formula can often be condensed. As you can see here, we decided that instead of writing it out 4 times, we're just going to write a little 4 subscript to represent that. Okay, so hopefully all of that made sense. We'll move on to the next question. Now, let's have a look. Okay, so I have a bit of problem sometimes finding the marker. Although it may seem like it's visible on your screen, it's not very visible on my screen, so sometimes I look for it, and I think I found it, yep. So semi-structural formula for this molecule here. Now, we can see that we have, this is a functional group, same as that there. So we have 3 different functional groups. So I can start with my semi-structural formula. I'll write the OH first. Now, a lot of the time it's important to write O positioned near CH2 because the oxygen is actually connecting to the carbon. It's not the hydrogen that's connecting to the carbon. So I would orient the question in such a way. Then we have CH, which is here. And obviously in this case you can't really avoid it. You have to then write that there's a functional group. And ideally, I mean in this case it doesn't matter if the nitrogen and the carbon connect, as long as you have brackets showing that it's a functional group. So NH2, like so, followed by CH2, which is this part, and then CH2 again, and Cl. Now with Cl you don't need to write the bracket because it's not in the middle of your molecule. Whenever functional groups are in the middle of your molecule, you then use a bracket. Okay, so providing the systematic name or the IUPAC formatting. So what we're going to do for that one is we need to refer to what kind of functional groups these are. So this is an amino functional group. This here is a chloro functional group. And finally, this one here is a hydroxy. So we're going to have to give them a position. Now, I guess we'll just make the hydroxy, we'll turn this into an alcohol. So that hydroxy will probably have, will be within the stem of the actual backbone of the molecule. So what I mean by that is, remember the molecule, the actual carbon chains, 1, 2, 3, 4. There are 4 carbons present. And so I'm going to position the OH on carbon number 1 because OH is quite strongly polar, and I'm just going to give preference to that. So in terms of naming this now, so we know that we have 4, so we have butanol. And of course, to be more accurate, you could say butan 1-ol. And then we also need to give position this is carbon number 2 with the name amino, and carbon number 4 with the name chloro. And yeah, so we go 2 amino. That's my attempt at writing amino. 4 chloro, butane 1 ol. Okay, so that's our systematic name. Right, so it is a bit of a challenge, especially when you have more than one functional group, to sketch it, to name all of these functional groups. So here, this looks like a cyclomolecule. Whenever you have an enclosed molecule, it's called cyclo. You've got 1, 2, 3, 4, 5, 6 carbons. Each of the edges are a carbon. And on this carbon here, if I wanted to write this out or draw it out, it would look like this. 1, 2, 3, 4, 5. I haven't drawn it properly, have I? Nope. Let me reattempt that. So we have 6 carbons, 1, 2, 3, 4, 5, 6. And then we have CH3, so 3 hydrogens here. And then we have a hydrogen there, and 2 hydrogens there, 2 hydrogens here, 2 hydrogens there, and so forth. Please don't write in this kind of way on an exam. You should always have your hydrogens labeled, but just for convenience, I haven't. But as a student, you should always, it's not about convenience, it's about representation, okay? So, semi-structural formula, in this case, I guess we know that we have 5 CH2s. We can see that we have 5 CH2s. They're all around here. We have 5 of them. And then on our last carbon there, which is this one here, we have 1 hydrogen. And then we have a methyl group. So that's a semi-structural formula. Now, to give it a systematic name, it's called a cyclohexane molecule. And it has a methyl functional group. So that's a methyl functional group. And so you can call it 1-methyl, but it's not really necessary to put the 1, just methyl will do. Methyl cyclohexane. Okay, so question number 4. So we have a semi-structural formula to write. We also need to provide the functional groups, which are these. And this whole thing is actually another functional group. So the semi-structural formula, CH3, CH2, CH2, CCl2, and COOH. So this is all a function, this is the semi-structural formula. Now in terms of giving the systematic name, remember that anytime you have a COOH at the end of your molecule, it's referred to as a carboxylic acid. So it's a carboxylic functional group. And carboxylic functional groups tend to be called, well, you first need to identify how many carbons the backbone has of the molecule. So 1, 2, 3, 4, 5. So it has 5 carbons. So probably it's going to be called pentanoic acid. The backbone of that particular carboxylic acid. Yeah, so this is going to be called pentanoic acid, but of course you have 2 functional groups. And they're both on the same second carbon. So I guess you have to give the position of each. So 2, 2. And then you have to say dichloro and pentanoic acid. Okay, so that's how you would name the molecule. Okay. So, this molecule here, it has a functional group right there. Now, don't confuse this for a carboxylic acid. This is not a carboxylic acid functional group. This is actually an ester. Ester functional group. Now, what we do with ester functional groups is we have to cut it up between, we have to separate the two parts of the molecules into an alcohol part. So it's going to be the alcohol component. I always struggle with spelling alcohol. And carboxylic. So the alcohol part of it is the longer one in this case, because it's just the part of the molecule that only contains one hydrogen with no double bonds. Okay, so if you count how many carbons there are, there's actually 5 carbons. So the alcohol component would be called pentanol. Okay, whereas the carboxylic part, this here is the carboxylic part, C double bond O H. So that's, because it has only one carbon, it's called methanoic. Okay. So when you fuse these two names from the alcohol and the carboxylic acid into an ester, the ester name for this is, you take the alcohol and you take that ending and you replace it with a YL. So it's called pentyl. And then with the carboxylic part, you take that bit and you replace it with O8. Okay, so it's pentyl methanoate. Okay, so that's a systematic name. Pentyl methanoate. Okay, so then the actual semi-structural formula, the way we will work that one out, I'll just make some more space by getting rid of all of this. And let's have a look at how we can provide the semi-structural formula. So we'll just start with this hydrogen first, H, and then we know we have a COOH group, so I'll just write it as COO. Sorry, it's not a COOH, it's COO. This is the ester part, and then followed by a CH2. And there's a few of the CH2 groups, 1, 2, 3, 4. So there's 4 of them, and then there's CH3. So this is the semi-structural formula of the molecule. Okay, so question 6. Again, you have to provide the semi-structural formula. So it's in this it's in this form, in the zigzag form, which represents carbons. Remember, each of the edges here represent a carbon. So I'll write it out. C, 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 with a double bond here, and then each of these hydrogens I will adjust my mistake. And my mistake is that each of these hydrogens that I've sort of automatically written here, they're iodines. So I, and then I. Okay, so as a functional group, that I is called iodo. So the semi-structural formula is CH3, then Ci2, then followed by CH, CH, and CH3. Okay, so that's our semi-structural formula. The systematic name for this would be, well, we would start, the double bond always gets priority, so we start 1, 2, 3, 4, 5. We wouldn't start from this side, counting from this side, because that would give the double bond the higher number. So we have to start counting from this. Because the double bond, this double bond, is going to get the number 2. It's on the second carbon. So the way that we would name this is, we know that on this, that first of all, this is a pentene molecule, but on the second carbon we have the double bond, so it's pent-2-ene. Okay, and then on the fourth carbon we have 2 of these iodo functional groups. So we've got 4, 4. Now we'll write iodo, pent-2-ene, and in front of that iodo we have to write diiodo pent-2-ene. So this is the name of our molecule. Okay, now it looks like it's a more challenging molecule next. I can hardly see it. Hopefully you have better eyes than I do. Okay, so we have 2 double bonds here. Then we have quite a lot of functional groups. So this is a functional group, so is this, so is this. And the length of this, I guess you could call this number 1 because we need to assign the lowest number to the double bonds. Then this would be number 2, 3, 4, 5, and 6. And so this is a hexene molecule. It's still a hexene because it contains a double bond. It doesn't matter how many times you see that double bond, it's still called a hexene. We will adjust for these 2 double bonds in a moment when we're writing the molecule out. So I'll show you how to do this. So hex, then you write down the position of the double bond. So on carbon number 1 there's a double bond, and so is there on carbon number 2. So 1, 2, and then you say diene. So it's hex 1, 2 diene. And then you need to also provide the functional groups once you've done that. So the functional group, there is a bromo functional group on carbon number 3. There are also 2 bromo on carbon number 4. So actually it would be, you would provide the systematic name by going 3, 4, 4. Then it's tri-bromo, hex 1, 2 diene. So it's quite a long name, this one. Now to give the structural formula, I'm going to start off from right there. Okay, so I'll just start off from right here, and then followed by CH2, then followed by CBr2, CBr. You can show that it's a functional group, and then CH2. So that's the semi-structural formula. Finally, we get to question 8. Question 8 looks at, let's have a look at this molecule. This is a can straight away recognize it. It's got a COOH functional group. That's a carboxyl. Okay. Also, we need to provide the length of this. So 1, 2, 3. So the systematic name would be, we definitely have a pent, no, not pent, pent is 5. We definitely have a propanoic acid. I always leave some space here because I don't know what goes in front. Actually, there's not much that goes in front of this because there are no other functional groups. You have a double bond here, but this double bond doesn't take priority over the carboxylic acid. So on the second carbon, we have a double bond. And so the way that we would explain this in the name, can you see how this is generally assuming that you had single bonds between molecules, because it's all that's happened really is the ane ending has turned into oic acid. This E here has turned into oic acid. So if we know in this case we have a double bond, so we have an ene ending. So it's called propanoic acid. Prop, and then 2-enoic acid. So that would be the name that goes up here. Okay, and the semi-structural formula, let's write this all out, CH and CH2. Okay, so that's the name of the molecule. So that concludes our tutorial about IUPAC naming. Thank you.